Hey guys, so volunteering and enrichment. So for this semester, only 6 volunteering hours are required. It was originally 12 and a half hours. Instructions are posted on our Remind and student website on how to submit your hours. And as of now, seniors still need to complete the 100-hour requirement for the academy by the second semester deadline. Good luck to everyone. Also, in continuation, two enrichment activities are required for this semester like normal. Submit your enrichment activities into the Engineering Academy Schoology, and you must fill out the attached enrichment form for all enrichment activities. Um, the enrichment forms can be found on Schoology and also on our student website. Also, in continuation for SBMs, you do not need to attach a photo. If you did, that's totally fine. Deadlines and requirements are always subject to change, so please make sure in our mind and look at Mr. Lamb's weekly newsletter. Enrichment in hours has changed and is due by December 31st, 11:59.
Hi, everyone. Again, I mentioned this last meeting, but the EA Booster Club is Academy Parent Booster Club. That's a nonprofit organization that supports us as an academy. So their goal is to create better experiences for us, get us speakers, get us events, different special activities. And it's a great opportunity that your parents can learn how to network with these people and they can aid in planning events for us. So if you get your parents to join the Booster Club, it only benefits us and allows us to do many more events in the future. So please encourage your parents to check out the EA Booster Club, and here's their website for more information.
So let's review the point system. So as most of you should know, the student's goal is to earn at least 16 points by the end of each semester, and if achieved, they can attend additional events such as special socials. Now let's review the point summary. So student body meetings are worth 5 points, field trips are worth 5 points, socials are worth 4 points, tournaments and longer challenges are worth 3 points, enrichments any enrichments not listed above are worth 2 points, and first place winners are also worth 2 points.
So last month, our total house points were for Tesla, we had 143, for Ford, we had 125, for Eiffel, we had 111, and for Curie, we had 103. This month, after the last student body meeting, Tesla is still in first place at 278, Curie is now in second place at 228, Eiffel is in third at 226, and Ford is in fourth place at 215. The competition is very close, so please encourage your friends in your house to come to events, and the house with the most points at the end of the year will earn a reward.
Hey guys, so a little message from your Curie House leader. Please come on, guys. I want to win the reward. So come to our SPMs and our game night that we're going to be hosting very soon. Come on out and I'll be there too to support you guys. All right.
So, as you guys may have known, the Instant Challenge and Rube Goldberg competition have ended, and here are the winners and the prize money they have won. So, congratulations to all of you who won, and amazing job, and thank you for your commitment.
Since a lot of people really liked the last game night and have been asking us to host another one, here it is, game night round 2. It'll be on Friday, December 18th from 5 to around 6:30, and we'll be playing Among Us, Scribblio, Codenames, and family-friendly Cards Against Humanity. So make sure that you sign up beforehand. You can pick who you want to be with for your groups. So make sure that you do that. Make sure to invite your friends, and you can also ask non-academy students to come as well. This event counts for 1 enrichment credit, and if you do sign up, the Zoom link will be sent to the email that you list.
Today we have Mr. Amir Aghajani for our special speaker, and he is coming from the HOK Architectural Engineering firm. So please give him a warm welcome And without further ado, go ahead, Mr. Aghajani.
Thank you very much, Janavi, for that great introduction. And thank you, everybody, for joining this meeting and listening to me kind of talk about a little bit about my career and a little bit about what I do and some of the things that I've done in hopes that you learn something and it kind of keeps you inspired as you pursue your career. So without any interruption more, let me go ahead and start to share. So I hope everybody can hear me and can see my presentation. Yes? Okay, great. So I work at an architectural firm called HOK, as some have stated. HOK, particularly in Houston, is a culturally diverse set of, and that goes from age range to male and female to culture to you name it. It's probably one of the more diverse offices we have in our global firm. We have all of the building related disciplines within at least our Houston office. That's architecture, structural engineering, electrical engineering, mechanical engineering, plumbing, fire protection engineering. We have lighting design, visual experience, which is like signs. If you go into like a building and you see signs, room signs, direction signs, that type of design work. So we offer everything: planning, landscape. Globally, the firm was started in 1955, and one of the major local projects that it started in St. Louis and then came to Houston. And one of the big projects that brought it to Houston is the Galleria, which I think everybody's kind of familiar with. These are the three gentlemen that started it: Gio Obata, George Kassenbaum, and George Helmuth. George Helmuth's grandson, Bill Helmuth, still runs the company, amazingly. So it's really interesting to work for one of the founders' grandsons, and I speak to him regularly. He works out of our Washington, D.C. office. And what I would like to focus on is specifically what I do and how we kind of relate engineering to the architectural world. So my career, when I walked into University of Houston the first time, I knew that I would be mathematics related. I would do something mathematics related, particularly engineering. I didn't know at that time it would be structural engineering. But as soon as I started to read the pamphlets and I noticed the great impact structural engineers have on the world, it kind of hit me, and I kind of found my why and my calling. And so I pursued structural engineering. I've worked for HOK since I got out of school in 2012 until now. And what you're looking at is my very first assignment. When you come out of school, it's kind of daunting. You know, you have all this teaching you get in the books. Everything in the book is a theory, and it kind of, you don't really get a grasp of how you're going to use it. You know you're going to use it, you just don't know how it'll work. And then you kind of get to your desk and somebody assigns you something like this. It's an outdoor stair, 140 feet long, curved radius. It curves 110 degrees, which kind of almost sweeps back completely to 180 degrees. Being outdoor, there was a lot of temperature range involved, temperature differential, which caused a lot of problems, not problems, but challenges that we had to solve. And it was kind of daunting. I was thinking in my head, where do I start? You know, and so in speaking to the good part about HOK and the good part about this field in general is you find a lot of teamwork. A lot of people will help you. A lot of people will get you from one point to another if you're willing to ask questions. So I encourage you to always ask questions. Ask me questions. Just keep throughout your career, throughout your schooling, throughout everything, ask a ton of questions, because that's what's going to get you there. So they presented me with this picture, and it was my responsibility to provide the frame that, and if you compare architectural engineering to the human body, right? The way the body, the person looks is the architect. The spine, the bones in the arms, the bones in the legs, the elements which keep this person upright against all forces is my job. So what you're looking at, if you wish, is the spine, is the bones of that stair. And no matter what I did, initially I could not get the stair to work. It would just keep bouncing as I ran the simulation. It just kept bouncing and I could not get it stiff enough to work. So I initially tried, if you can see here, I initially tried putting little trusses, vertical trusses that look like this all along the entire span of the stair, and it did nothing for me. So I said, maybe I can do it vertically this way, similar to what you would see in a bridge. And I tried that. And again, I noticed nothing was happening. In a way, you can tell in engineering that you're not going down the right path is, particularly in structural engineering, if you keep throwing material at it, if I keep adding steel and it keeps getting heavier, but the numbers don't show, numbers speak to you in many ways, and they kind of tell you what's going on. They actually, not kind of, they do tell you what's going on. The numbers told me no matter how much steel I threw at it in this solution and this solution, it wasn't doing anything. So I knew something was awry. So I said, okay, what if I didn't do any elements in the vertical? What if I tied it together horizontally? That means in bird's eye view, you would see these X's if you were looking down at the stair. And lo and behold, instantly it tied this thing together. It stiffened the stair and it didn't move. And I was on cloud nine. I was at home. It was 2 o'clock in the morning. And I went in the next day, ran to my boss's desk, and I said, I think I solved it. And at first, he kind of didn't believe me. He's had a senior engineer check my work. And they both, I could see them from across my desk, and they both were like, I saw that reaction on their face that it works. And so that was the solution that we implemented. And that's kind of, in a nutshell, what we do as engineers. We take a challenge. We take what we learned in school, theory. We try our best to apply that in a very real sense, in a practical sense, and come with a solution that is efficient, safe, buildable, and meets budget concerns and schedule concerns. And this seemed to do all of those things. So when they went to when in the field, when they erected this stair, and these are real life pictures here. This is the final stair condition. When they erected the stair, they do something called shoring. Shoring is the temporary support. So you'll see temporary supports here as they're building. And they called me and they said, hey, we're about to take this temporary support out and we want you to be here. So, and this is a very nerve-wracking moment for any structural engineers, that when they come and they say, okay, we're going to remove these things one by one. So I went to the field and I kind of stood off to the right somewhere here, and my boss was with me, and we told them, usually in a steel structure, when those shores are removed, you instantly hear a loud bang. What that bang is everything setting together, bolts, welds, everything kind of locks and it starts to behave in self-support. And I thought we're going to hear this loud bang, but I was sure with my numbers, and always, as you become engineers, always trust your numbers. If your numbers are right, don't instinctually think something might happen. If your numbers describe to you what's going to happen, that's exactly what's going to happen. That's another beauty about engineering. So they removed the shores, and right when they removed the shores, I ran around a column and kind of hid. It's the first time I've ever seen this, so I didn't know what to do, and they caught me kind of run around and hide, and the stair didn't move. There was no bang. There was nothing. It did nothing. And I was kind of waiting for it to do something. It just did nothing. It didn't move at all. And I knew that would happen in my gut. That's what the number said. We just kind of you get scared. And I came around the corner and there was this applause and everybody was happy. And that's the current condition it's in now. And it hasn't moved a bit. And this stair, actually, this is in a company it's in an oil company, Shell's campus. And every year they take the entire staff of this Houston campus, and everybody lines up on the stair for their annual photo, and it gets loaded to the max. Usually you don't get conditions where structures are loaded as you design them, because you have it's kind of a probability thing. Any given office floor, you're never going to have the entire office be completely loaded with people the way you design it. But in this case, it gets completely loaded every year, at least once for an hour or two. And it stayed there and it's just fine. So what I'm going to do is kind of, I show you, this is my initial, now fast forward 9 years, right? And I started to get into the design of really monumental structures. So the busiest, a little fun fact, the busiest airport in the world is Hartsfield-Jackson, Atlanta's airport. I don't know if anybody's been there or had a chance to see it, but Hartsfield-Jackson is the busiest airport in the world, not just the United States, in the world. And this is a picture, a sky picture of Hartsfield-Jackson before we modernized it. And we won a bunch of awards for this modernization. And what they wanted to do is cover these roadways. This is how you enter the airport. You come in and walk into the airport on both these sides and check in and stuff. And once you check in, you walk into the terminals and onto the concourses to go to your airplane. So they wanted to modernize this completely. It was a $200 million project. And this was the initial picture we showed. The plan was to cover those roadways with these huge steel trusses. And so this was the first time that they asked me to travel. And I was like shocked. I was like, wait a minute, you're going to send me to Atlanta every week and I'm going to stay in a hotel and design this thing for a year and come back home. And like, yeah, that's exactly what's going to happen. So for a year, I went every morning, Monday morning, 5 a.m. I flew to Atlanta, flew back Friday evening. And in specific, my part of the design was the concrete supports that would go down into the ground and support these steel trusses. So I wanted to also kind of give you an idea of how this process works fairly quickly. So the architect shows us these sketches. They sit in a room. They say, okay, we're going to modernize these roadways. We're going to cover them with canopies. What are your ideas? Engineers aren't really there for this process. Sometimes we are, sometimes we're not. A lot of times we're not. So they start to sketch their ideas, what's in their brain. And these are called sort of hand sketches, rough sketches. There's no rhyme or reason. Whatever's in their head, they put it on paper. From there, we start to model these things. We start to say, okay, what's going to work? What doesn't? In an initial sense, strength-wise, is it going to move too much? Is it doable? Is it buildable? Are we getting crazy here? So we narrow down all those sketches into a few ideas. We begin to model those ideas. We model those ideas, then we go back to the architects and we say, okay, look, these are of those sketches, these are what works. Let's start to narrow down the way we're going to go. When they looked at this, they elected to go with the bottom left-hand corner, which are those giant, they call them cheetah trusses, because they kind of sweep. The way they sweep, the architect referred to it as a cheetah shape. So, because it has motion when you look at it in section. And so the cheetah truss became the direction that we went. So here's the cheetah truss, kind of a overall look at it. It's covered in a material called ETFE. This is a really new, really cool material. You can embed LED lights in it. It's kind of translucent. If you can picture in your mind sort of a balloon, a thin-shelled balloon. It's that on a very large scale. It has stiffness in plane, right? So it means if you pushed it together, it wouldn't fold up like paper. It has stiffness in this direction, and it's fully powered. Whenever you land at Hartsfield-Jackson now, they put signs in LED. Like when the Super Bowl was there, they had the team names and LEDs on here. You could see them from the airplane. It's a huge sort of huge thing from any angle. This thing is really imposing. And my job was this thing right here, 38 of them. And these are piers which take the load of these trusses and send them down into the ground. So again, even I'm doing this 9 years, I look at this and I'm like, oh my God, this is going to be at the busiest airport in the world. It's going to have to be there at least 100 years. And the responsibility kind of, the great part about the beauty of this job, this field, is once it's done, the gratification you get is amazing. All of the struggles become worth it. When I go to Atlanta and I land at that airport, all of the responsibilities, all of the headaches, all of everything that challenged me, that challenged the team, becomes worth it when you see these things. So I'll go into a little bit about how that looks. And so once we knew everything, how we're going to do it, we came up with how we're going to present it to the client. So this is a kind of a rough graphic animation that we showed the client. So this is what you'll see as you come into the roadway. And you get this really imposing cover that shields you from rain, but you can see through it. That's really the crazy part. And all that translucent screen has lighting in it. Like I said, I mean, and the architects are free to do whatever they like with it. So here comes the challenges I was posed with. So they handed me this, okay, you're going to design the foundation. You're going to design these piers, concrete piers that catch this truss. And they handed me this plan. This is when I showed you the roadways. Imagine for yourself, the roadways come across on top of this plan, this way and this way. So below here, the canopies come like this. And here's the airport itself. So below here is where the baggaging, when you put your baggages, it goes through these little baggage machines and then finally into the airplane. The challenge was, if you can see the red boxes, those are piers, those are my foundations. The red means there's nowhere to put anything. I can't do it. And just to give you an idea about airports, a lot of big chunks of all airports in the United States are owned by the federal government. It's not privately, it's not commercially owned. The United States federal government owns it. And these red boxes are areas where I can't really do anything. I can't ask them to break a wall, go in there and put a pier. I can't ask them to really touch at all these red areas. The yellow areas are, well, maybe you can. We don't know yet. Assume you can and design it that way. And then the green are do whatever you like. So I sat there and I thought, okay, I need to come up with a solution that whether the color is red, yellow, or green, that they can proceed with that. And eventually what I came up with is, so this is the pier itself. This sticks out of the ground, as you can see. The top receives that metal, the end of the metal truss. So you have to picture the metal truss sweeps all the way like this and lands on this pier. So what I came up with is the use of micropiles. And after this meeting, I encourage you to go look up micropiles and see why I used it. Micropiles can be installed. They need to be installed. They're like 9 inches around. They're tiny little things. And in order to get load resistance, they use skin friction. It's the surface of the pile against the dirt that holds that pier up. And so they go down 300, 500 feet sometimes. The machine that drills micropiles only needs 8 foot of head clearance. And all of these federal spaces I knew had 10 foot of head clearance. So what I did was I designed this foundation system such that the placement of these micropiles are not set in stone. This portion varies. So they can spread this footing as much as they like. And based on how far it's spread, the reinforcement changes. And I put all that in the drawings in a schedule. So if they're in a red zone, they find where they can place. If we're looking at this thing, if we cut through this and look down, suppose that, just quickly here, suppose that we have an area here which we cannot touch. Well, what the contractor would do is place the micropiles here. And based on this distance, he goes to the schedule and reinforces this thing as my schedule says. And so that's how I came up with one solution that takes care of the entire complex on the airport. And so that the contractor was quite pleased about that. So again, this is on a much broader scale, what I did with the stair and what we do as engineers, but apply it in a much larger scale with one solution that meets many challenges. So this is a graphic of the current condition or the condition before the canopies. This is as they were building the canopies. These things were built in segments. The segments were, we told them exactly in which order to place these canopies, and they came in and placed those canopies per our instructions. And this is the final condition of the canopies as they are now. It's just a simple graphic of that. And you can see just quickly here, this is the pier, and people walk on this level. And you have to imagine here that this is the cap I was showing you, and micropiles do this 300 to 500 feet. And this area here is where I knew the machine that can drill the micropiles can fit in. So they go in there with the machine and start to drill. And based on whatever anomaly is in the way, they spread these micropiles as they like in the field. And that turned out to be just a perfect solution for this case. And eventually, like I said, how they proceeded to move forward. And so in a nutshell, in 9 years, you can see that my job really hasn't changed. It's just I honed those skills that my boss taught me and learned how to coordinate and collaborate with my partners and teammates and stakeholders to come up with unique solutions as an engineer that meets many challenges and meets many requirements. And the really gratifying thing is once this is all done, once the 2 a.m. nights where I'm working on this, or the 5 a.m. flights to Atlanta, once it's all done, when it was done, this was in 2015, flying in here and seeing it, I mean, it's a really, really a wonderful feeling. It's not about the money, it's gonna, if anything you do that you do well, that you enjoy, you'll get paid handsomely eventually. But it's this feeling you get. I can take my parents and sit my mom on this roadway and say, look at this thing. I did this, and it's really incredible. It's really, really a wonderful feeling. This is a real picture of the roadways before. This is a graphic of what we showed this trusses to look like. And then this is a graphic at night. We wanted to show them how the lighting would look. That entire translucent film has LED lights embedded in it. It's really, really crazy and really awesome. And I encourage you to Google Hartsfield-Jackson canopies after this and look at what they've done with these LED lights. It's really, really mind-boggling. And so in a nutshell, engineering-wise, that's what I do. And that's how and that's what I'm doing right now, meeting challenges and working on things daily. So with that, I'll open it up to questions about anything.
Thank you so much, Mr. Aghajani. So one of our students asked, how important would you say that communication is within architectural engineering?
That's a wonderful question. That's an excellent question. Communication is the #1 skill that you need to actively do in the field of architectural engineering or any engineering. Listening, when we say communication, what I'm really saying is listening. Active listening is a skill that can take you to many, it can do wonders for your career. It can do wonders for your ability to solve problems and solve challenges. Sitting in a meeting room with your colleagues, with your teammates, with stakeholders on any projects, and just listening, I can't begin to tell you how important that is. And not just in engineering. I mean, this is just in human to human relation, human to human communication. Listening and communication is your #1 skill to hone in on and do right.
Awesome. So another student asked, what programs did you use to develop your design?
Excellent question. Excellent question. So we use our #1 program we use is called Revit. It's an AutoCAD product. It's 3-dimensional drafting software. Once the buildings or whatever element it is gets drawn up and gets shown in a Revit model, once it comes into my hands, I take it into 2 programs mainly, many structural programs, but in specific, most of the time we take it into 2 programs, SAP 2000, that's SAP 2000, and ETABS, ETABS. SAP stands for Structures and Programs, and ETAB stands for Enhanced 3-Dimensional Analysis of Building Systems. I use those 2 programs to communicate with Revit back and forth and Revit will send a framework to those programs, and I will begin to start doing analysis, applying loads, applying temperatures, applying everything that I anticipate, and the code tells me to anticipate in the field. Once I have that set in stone, and once I see that my solution works, I then send that back to Revit via the architects.
Awesome. That's very interesting. So, what would you recommend to a student wanting to become a civil engineer or architect?
So civil engineer is a little bit different. So what I can tell you, simplify the difference between a structural engineer and a civil engineer. We delineate our responsibility at the line of the dirt. Civil engineers work at the dirt level and below. That's drainage, sewers, dirt work, earthwork, sometimes foundations. Anything to do with the ground and below is usually civil engineers. Now that's the only time that kind of gets cloudy is structural engineers. We like to say we're ground and above, but we also design we're responsible for the foundation system of buildings, like that pier is a foundation system, and that gets into the ground. And for architects, civil engineer, structural engineer, what I would recommend is stay focused, stay in touch with people that are doing it. Like I'm open to all of you. Anytime you want to communicate with me, I'm going to give my information to your teacher, and he can distribute it as he likes, and you can always stay in touch with me. Stay involved with these auxiliary things you're doing, these, clubs, ASCE, architecture, like professional organizations. Stay involved with those. Stay ahead of exams that you need to take. Don't wait for those exams. Don't get out of school and just wait and let that exam catch you by surprise. Do those things in advance, and listen well, and find what niche in this whole sort of world of architecture you like doing, and that'll be what you end up doing well.
Another student asks, has something ever not worked, and what did you do next?
Great question. Great question. So as humans, we make mistakes. It happens. It happens in our field. It happens all the time. And there's different phases where we catch things not working. Sometimes I give it to the architect and I realize later, oh my God, that thing I gave them doesn't work. And we can catch it before it's built. And we solve it, we explain it. And then sometimes it gets built and I realize later, oh my God, it doesn't work. What I can tell you about mistakes, other than all humans make them, I still make them now 9 years into my job, is we have a saying in our company that we say, run to trouble. What run to trouble means is stay ahead of it, be honest, get ahead of it, tell people when you find it, and just fix it. 9 times out of 10 people will work with you if you're completely honest and say, hey, this is what happened, this is a mistake. And whenever you do find that something doesn't work, before you go tell somebody that it doesn't work, have a solution in mind.
So here's a specific question about one of your projects. How is construction done with the airport being so big?
Great question. Great question. So it's not just the size that was a challenge. This airport never stopped serving its passengers during the entire construction process. The only time it stopped, they gave us windows of 2 hours in the middle of the night where we could come in, do some work, and leave. Otherwise, this airport had to be functioning the entire time. So you see these giant shores here. These are temporary supports right here. What we had to do is learn how the airport functions first, then work with the contractor. The contractor is the guy that's going to build it, and find out what tools are available to him or her. And once we know, we have a good idea in mind that what we can do, we begin to schedule and organize a way to get around not just the size, but around the traffic, around the functions that cannot stop. This portion down here, which is federally owned, The United States government owns this, could never stop for a minute. So we had to compartmentalize, in other words, take pieces of it, slices of it, and schedule those slices in such a way that didn't interrupt services at the airport. And that was really, that was one of the biggest challenges. And it's when you have those kind of challenges, not just size, but when the client says, hey, I can't stop working, you have to do what you do without us stopping, then we get really, usually we don't get that involved with the building process. It's kind of a hands-off but helpful approach. In these cases, we're totally hands-on. We're there on site. We give them areas that they can do. And then not just that, when you temporarily, in other words, like this thing that's not connected to anything, we tell them what to do with that half-built segment to hold it in place while the airport functions, and they come back to add this piece. And that happens a lot. Partially built elements and how those partially built elements stay stable during the process.
So going off another one of your projects, a student asks, how many nights did you spend brainstorming ideas?
For the stair, that was a really difficult one because it was my first. And each one of these each one of these windows is a solution. And I think I spent 2 to 3 nights on each one of these solutions before I was able to nail down one that works. And once it works, from this kind of skeleton frame until you see it in drawings, was about 2 months.
Wow, that's a lot of time.
Yeah.
So another student asks, what part of your job do you enjoy the most?
The part of my job that I enjoy the most is once everything's built, once it's in this shape, in this form, it's just, I can't begin to explain to you the gratification you get in looking at something that you know will be there as far as you're concerned forever, and that you had a big part in making sure that it's a safe thing that people will use, people will enjoy. And it kind of plays into this statement by our founders here, which is serving humanity is at the core of what we believe. And that's really true. When you see these things and people are using them and they're smiling and people are eating at the, on an elevated floor, and it's just like all these things are happening, and it's in getting into people's lives and they're enjoying what you've done, and they don't know you did it, but it's you've served them in some way. And that's the most gratifying part. That's for all architects, for all engineers of any field.
Another question is, if you are really good at math, but not too good at physics, do you think it'll be easy to land a job in the engineering field or in your field specifically?
Absolutely. Absolutely. You don't necessarily have to be good at physics. Being good at math is great, but a common misconception is you have to be good at math even to become an engineer. You learn to become a good engineer once you start working. It's great to be an excellent student. It kind of kicks you off, ahead of the pack a little bit, if you wish. But the way you learn to become an excellent engineer is, it's great to have fundamentals in math. Absolutely. Fundamentals in engineering, even better. Not necessary. You learn to become a good engineer once you start to do it practically, as in a profession.
Another question is, what part of your job do you dislike the most?
That's also a good question. The part of my job I dislike the most is sometimes you'll design things for months and months. And like I said, 2 months to get something on a drawing like the stairs, and the client may change their mind. The architect may change their mind, and it changes everything. Sometimes you don't get paid for that change. So you kind of scrap a whole slew of late nights and work for a brand new idea. Sometimes that brand new idea is the best idea, but I would say that part of my job I dislike the most is going back and reworking things for a late idea, which happens honestly quite often.
For our last question, we have, how are you able to calculate every factor that can affect the buildings?
Good question. Excellent question. So that part is it. They relieve us of that responsibility kind of with code books. So we design steel with steel codes, concrete with concrete codes, and those books tell us exactly what to consider. Now, sometimes we make mistakes and we even though it spells it out for you step by step by step what to consider, sometimes we miss something, but we refer to those code books to know exactly what to consider. And then sometimes we use engineering common sense to also consider things in addition. For example, the stairs. Probability wise, any office floor, even your apartment, your house right now, you're sitting in your room or wherever you are, you're sitting there, your entire floor, there's nobody there. You could have your parents or family in another room, but your floor of your house was designed in the assumption that there's 40 pounds every foot. Now, probability will tell you that probably is not going to happen very often. But in the case of the stair, I knew that would happen. They told me, hey, this is going to be used for a photo opportunity every year. So I knew that it would be loaded to the max 100%. So even though the code told me I can reduce that, there's a part of the code that says you can reduce loads based on probability. I didn't do that. I knew that, hey, this is going to be loaded fully at some point, one or another. So outside of the code telling me exactly what to do, I introduced that one little change.
Yeah, that makes a lot of sense. Again, thank you so much to Mr. Aghajani for presenting and all about HOK. It was really interesting to learn about your experiences, and I'm sure it helped a lot of us learn about what we want to do as well in the future. So now we're going to finish up and conclude. Thank you so much again, and I'm sure we all enjoyed your presentation.
Thank you all for your time. I enjoyed it as well. I hope you guys took something from it. Again, I'll give my information to Janavi and your teacher, and you're more than welcome to contact me anytime for any question you have along your career path. I'm more than happy to help you or answer questions along the way. Thank you all so much.
Thank you. Okay, so before we conclude, just a few things. One, listed above in the PowerPoint is the email for Mr. Lamb. So if you have any questions or if you want to get in contact, just email Mr. Lamb and he can probably get you his information. Also, important websites. We have the FASD Academy website and then also the student website. The student website has everything from enrichment opportunities, volunteer opportunities, and socials and student body meetings. So make sure you check that regularly so you can be up to date on any events that are coming up and that we have planned. Also, for your parents, if they can look at the Booster Club website if they would like to be a part and contribute to the Elkins engineering community. Lastly, for social media, we have our Instagram and Twitter at Elkins Engineers, and then also our YouTube channel if you guys would like to follow us, Elkins Engineering Academy. So you guys can check all those resources out, and if you have any more questions, feel free to ask.
Also, don't forget to review us, guys. Just remember that your opinion is what helps us make our SBM better, our game nights better. So please leave your review on our SBM and we'll make sure to improve our meetings as to what you guys comment on. The link is in the chat.
Another thing about the event review, if you guys have any questions that you'd like to ask us, Mr. Lamb, or the Academy, anything at all, you can go into the event review and on the last question, there's a place where you can put your email as well as your message. And if you do that, make sure that you input your email correctly. We'll get back to you in about a day. So if you have any questions from anything at all about the Academy, then once again, you can do that in the event review. And we'll take questions at the very end. So that is about it for this meeting. thank you guys so much for coming. Have a safe and happy winter break. Remember that your volunteering hours and enrichment ops will be due on December 31st at 11:59. Enrichment opportunities will be due on Schoology, and volunteering hours are due based on the instructions that we posted on our website. If you, as well as a reminder, if you are a face-to-face student, you can turn your volunteering hours into the counselor's office. And if you're an online student, then you can follow the instructions that we've posted on our website. There's an email that you can send your hours to. And once again, if you have any questions, feel free to put those in the event form, the event review form. We will get back to you really shortly. Or if you want to message us on Remind, that works as well. Thank you guys once again for coming, and we hope to see you again soon. Bye.
Bye. Have a
Remember,
good day.
Curie House is the best, so invite Curie members and come to our SVMs and game night. I'm counting on you guys to win me that reward, or win us that reward, okay?
I have a question. When is the next game night?
It'll be on Friday, December 18th at 5 p.m. So that's the day when finals are over, when winter break starts.
Okay, thank you.
Yep, no problem.
Will we need to take a screenshot to prove we were here? Because I came in a little late.
For student body meetings, you just need to fill out the enrichment form. No picture is necessary.
Okay. And also, I signed up for the game night, but I put a wrong email and I can't change it. So what should I do?
You can just sign up again. We'll delete the old one.
Okay. Thank you.
Yep, no problem.
Hi, I had a question about the citizen archivist, a volunteering point out. How will you be counting hours for that?
For volunteering opportunities, we normally don't set the guidelines, so you'll want to check with the event organizers or with the yes people. So you can find more details on their website or on the event organizer's website. If there's something that that might need clarification, then I think that you can contact the event organizers. They'd probably be able to tell you more.
Okay, thank you.
Yep, no problem.
I left the email for you, so you can email the person whenever you need to.
Oh, thank you.
Also, do you guys enjoy Home Alone music? Like, let us know, and then we can change up the music to y'all's preference too.
No, Home Alone was cool.
All right, thank you.
All right, if you guys are still here, we're gonna be slowly moving you guys to the waiting room, so you guys can, if you're here and you can hear me, and you're not away from keyboard, then you guys can go. Have a good day.